Now we can analyze the 2D beam, continuous beam under the influence of UDL and point load, having a two span and having a depth of say 0.6 meter and a width of 0.3 meter, can be analyzed by starting uh, by clicking on to this new project. Click on to space, then type 2D beam, 2D beam, and we need to check the locations and click on to the uh, meters and kilonewtons for force and length. These are the units which we are following for modeling beam. Then click next, then click finish. After that one, we are entering into the continuous beam analysis window in the STAAD. So now we are going to click on to snap node beam. We will cut on to this one, close this one. After that, we'll type a continuous beam having a three nodes. First node is 0, 0, 0. Next one is 5, 0, 0. Next one is 10, 0, 0. We have three nodes here. These three nodes can be created as a beam just by clicking onto this one window, then click onto this beam, select these nodes. By doing that one, we will get in, we have created a two span continuous beam. Go to the front view, then click onto the general properties. For creating property, define, go to rectangle, depth is 0.6, width is 0.3, click add and close. Then click, by highlighting this one, select assign to view. Now what we have to do is we need to create a support. For that one, go to general, supports, create, fixed, add, and we have one more type of support that is called roller. In this one it is called fixed, but uncheck this one. By checking that one, we are releasing all the other directional degree of freedoms. Click add. This now our first node is a fixed support. Click on to use cursor to assign, click assign, then click on to the roller support. It's already in the assign mode, just we need to click on to that node, then click on here. So and all these interior and exterior nodes are roller supports. So if node is not visible, just try to see in the middle. Now we can see that all the support conditions are already given. Next one is go to general, loads and definition, load cases and detail, click add for applying loads. Click on to dead, type DL, click add, then type live, type LL, click add, and go to auto load combination. Go here, select Indian code, generate loads, click add, close. From here we can see there are two load cases and four load combinations. Now we need to create a load inside the load cases. For that we need to click on to dead load, click add, select self weight, it is in y direction, minus y direction, click add, close. Click on to this self weight, highlight the assign to view. So self weight is assigned to continuous beam. Then click on to live load, click add, go to member load, type minus 25. This is UDL throughout the span of the span UDL is present, so click add. Next, concentrated force, it is applied on the member, and this one is minus 50 and at a distance of 3 meters from the second span support, that is left support. Click add, close. So now we need to assign this one. By clicking onto this window, all the selected elements are unhighlighted. Now we need to select on UDL, click use cursor to assign, click assign. So now we are going to click on this one. Now UDL is applied. Next one is click on to concentrated force. Already it is in assign mode, no need to click, just click onto this one. So now you can see here it is 3 meters away from this support, 2 meters from this support. Click yes. Now we need to see the loads values and in the scale. For our confirmation, right click on the mouse, go to labels, type load values, then select load values, then scale point force you increase to 30 per 30 scale, just apply. So now we can see that all our loads and loads are visible on the continuous beam. Click OK. Now all the loads, everything is applied. We need to analyze this one. So go to command analysis, perform analysis, click all OK. Command post analysis, print analysis result, yes. Then analyze, run analysis, save. So now we are going to analyze the beam, continuous beam, and we got a result without any errors and warnings. We are not going to now see the output file. We are going to stay in the modeling mode and click done for the design purpose. So we need to click on to design concrete, go to this drop down menu and select IS456, then select the parameters. All parameters are unwanted. Select only FC and FI main, click OK. Then we need to define those parameters, give a value for those selected parameters. 30,000, click add. Here FI main is 550,000 kilonewton per meter square. Click add and close. FC main, FC main, FC we need to assign to view. Click on to FI main, assign to view. Now we need to design beams and quantity of material. So for that, go to commands, go to design beam, add, take off, add, close this one. Now there only I can assign that one, but for the purpose of understanding, we can go select design beam, assign to view. Beam design is assigned to these horizontal members. So then go to analyze, run analysis, save. Now we can see that our analysis and designs are completed with it has created bending moment, displacement, all those files are created. Now we will view the output file. Click done. Here we can see the concrete design. Now we are going to see the concrete design. Click onto the concrete design. We can see the beam design. Beam number 1 having a FE 550 and FE 450 is there given, and M30 concrete is given. Length, area of reinforcement, top reinforcement, bottom reinforcement, everything is given into this one. So we have two beams, two beam design is given, and in the end concrete takeoff was also given. So weight, total volume of concrete is this much, and we can easily calculate the analysis. In the analysis, steel quantity calculation is not calculated. So we can see the forces, everything, bending moment, reaction force from this output file. Now we'll close this output file, go to mode, post processing, remove this two, then select this, click OK, then go to node, then click onto this reaction, second one. Here we can see that by clicking onto this one, we can see the reaction forces for this beam. Due to roller support, only Y reaction is there. Due to bending moment, MZ, Fx and Fy forces are present in this uh, beam. Horizontal forces are zero in all the things. This one we can see. Next one is the displacement. Now displacement is happening, but it is in a very micro level. So we can see by right clicking onto the beam, go to labels, go to scale, and we can change this to around 15 or something. So we can apply, means you can see 15, it is 5. If you type, it will be much more. Then okay, this will be the displacement of this beam. Due to point load, there is more displacement in this span. Now we'll go to beam. Here we can see the bending moment, where bending moments are zero at the roller support, and the bending moment is maximum around the fixed support. We can see the bending moment values. Go to result, view value, go to beam result, select maximum, annotate. So we can see that maximum bending moments are visible in this one. So we'll remove all. Now we'll go to beam graphs. Here we can see, by just by clicking onto that one, we can see the bending moment and shear force diagram here for the better design. Here we can change the for the different load combination, how the bending moment and shear forces are changing. We can select the maximum for the design. Now last one is go to animation. Already we have checked the change scale. Go to section displacement, click apply, click OK. Now we can see the displacement in the continuous beam. So we can right click, escape, right click, go to scales, labels, go to scales, and we can change this one to, like, let's say 0.5. You'll see how much it will be displacement 1. Okay, then we'll go to section displacement, click apply. Here we can see the displacement of a continuous beam. With this we are going to end this